All right. Let's do these ones. Okay, so cube root is 2 to the power of 1/3. A square root then is 2 to the power of 1/2. But if we want to move it up to the numerator side, you could do 2 to the power of -1/2. Yeah? Yeah, that all makes sense. 4, okay, we want to write it as a power of 2. So that's the 5th root of 2 squared. And the 5th root is 1/5. So you could put in you can put in an intermediary here of 2 times 1/5, but it's 2/5. Yeah. Like a kind of middle step. Yeah. Okay. I want to solve this without a calculator. Usually go to the base here. So 8 is 2 to the power of 3. And I think the 3's would cancel here. Multiplication 3 and 3 would cancel. So we're actually left with just 2 to the power of 4, which is 16. This one is 3 cubed to the power of -1/3. Yeah, so depends on what we want to do. We could write it like that, or you could have started 1/27 to the 1/3, which might be nicer. Yes, because if you want to bring the power down, you would change the sign. So if it's written like this, you can put it as a denominator and then have remove the negative sign, which might be easier. So maybe this one's easier to go with. So 1/3 cubed to the 1/3. So cubed and cube root is going to cancel each other out here. We're just going to... No, 1/3.
Oh, sir, it is 2/3.
Is it? Oh, in the question? Oh, well. Yeah, I've taken it down like this. So you would just, if it was 2/3, you'd just square that 3 and it'd be 1/9. This one, which we had similar one in an exam and wasn't answered particularly well. So if I multiply each of these by the thing in front, I just add the powers. So x times x to that -1/2 times this, you end up just adding the powers. So adding fractions here is just going to be 1, isn't it? So this is just x. And you just repeat that process if you want. 2x and this, add these powers, -1/2 plus 1/2 minus 3x minus 1/2 minus 1/2. So I'm just combining by adding the powers. So the first one is just x. We've done that. -1/2 plus 1/2, that's 0. So what's x to the power of 0? 1. So this just becomes 2, isn't it? 2 times 1. It is a constant term, as we know from binomials now. What's that? -1/2 minus another half?
-2 over 2, which is -1.
-1.
3 over x. -3 over x.
Yes. So 3x to the power of -1 is 3 over x. Okay. Something you mightn't have done before is to factorize something like 2 to the power of n plus 3 plus 2 to the power of n. How would I factorize this? What would it look like if it was factorized? What's the common factor between the two? 2 to the power of n looks like it's in both, but how do I get it out of this?
You subtract this root to the n.
Root?
Like to the nth power.
So I'm going to take out a common factor. What am I left behind? That's what I'm asking.
1 to the power of 3.
1 here, okay, but what's here?
1 to the power of 3.
1 to the power of 3.
Am I wrong?
You're wrong. Now you could test that out. 1 to the power of 3 is just 1, and then that multiplies, doesn't give it again. So what do I need? So maybe an intermediary step would help. If I unadd these two, what do I get? Don't I get that? It's the opposite of what we've been doing. We've always been adding the powers, so when we multiply it here, we automatically put these two together. But if I wanted to undo this, I would put the bases back in.
But sir, wouldn't it become 4 to the power of n?
That's what I was thinking, but that's wrong.
Why? That's how you multiply.
No, because when you multiply, everything stays the same. The base unit stays the same.
It'd be,
Oh, of course.
that would be it, this factorized. Okay. Let's do another one. You see another one here. Let's factorize that. Let's do the last one. 2 to the power of 3n plus 2 to the power of 2n. How do I factorize this?
2 to the power of 2 on the other side.
2 to the power of 2n outside the bracket. Okay. What's in?
And
1 here.
2 to the power of n. Just 2 to the power of n.
Yes, because if I add 2n plus this, remember we're add the powers and multiply. 2n plus n gives the 3n. Okay? Awesome. We're going to factorize more now. This first one, 4 to the x minus 9. I want to factorize this. Now, quite obviously, there's no common factor between these two, so how do I factorize?
Just leave it. It's just
Leave it.
leave it. That looks fine.
oh, it's 2 squared and
Difference of 2 squares, yes, but
2 to the power. So it can be
what's this as a square?
2 squared.
2 cubed. No. 2.
Oh, there's an x. Hold on. 2 squared in the bracket x. Bang.
Okay, you're on the right track. Yes, so if I wrote this, maybe it'll be easier. Maybe I can write that again.
2 squared.
So what's the square here? Is that the same as that?
Yeah.
Okay, so the square here, these are the two squares that are difference. So what's in my first, how do I write my difference of 2 squares then? Can you remember?
Oh, yeah. 2 plus minus.
We know one is plus and minus.
A plus b, a minus b.
Yeah, so it's 2x plus 3 and 2 to the power of x minus 3.
That's
Wait,
nasty.
hold on. How do you know that? Oh,
That's difference,
No,
yeah.
I got it.
Okay,
I don't like that at all.
it's like when there's a no middle term in the quadratic. If we've x squared plus 9, you could do the quadratic x squared plus 0x plus 9. It wouldn't be plus 9, it'd be difference of 2 squares, sorry. Minus 9. And then you can factor this out so that the middle terms make a 0 in the middle.
But you can't simplify 4x plus 9, right?
No, that's not the, yeah, it has to be minus. Difference of 2 squares. Difference is subtraction. Okay. This last one we see at the bottom of the screen here.
Get like a trick question and test 4x plus 9 just to like.
Well, then you would know it's not difference of 2 squares.
I think I will try to solve it.
Yeah, I would try to
Yeah,
solve
maybe.
it. It's 20 minutes on that one question.
All right, so this now. What does that look like? I want to factorize again. So, anyone see a quadratic here? No?
Do you see it?
I see a quadratic, yeah.
Wow. Wait, what's the square?
So if I write this as 3 square like this, yeah?
Yeah.
And then rewrite it again, 3x like that. So so maybe you don't like the way this looks, but if I just say, okay, a is 3 to the power of x, I can write a squared plus 4a plus 4.
Of course. But a is not 3 to the power of x.
Oh.
Could be. No, it's 3 to the power of x, because the squared I've kept.
It's a quadratic.
That's stupid.
So if I factorize this now, what's my a? What's 2 and 2 and plus and plus? But it wasn't a, it was 3 to the x. Now what I did there is just substitute the variable for an easier variable. So sometimes later on in IB maths you'll get stuff like sine x squared plus 4 sine x plus 4. It wouldn't be have a bracket there. But if something like this you want to factorize, or you just say, okay, I don't want to deal with writing sine x a lot of times. I just go, oh, exchange the variable for something easier just to read. This comes later. Same can be done here. It's easier to exchange the variable and then work with just a normal one variable, and it will work the same. Okay, you can practice these in a while. Let's do some more solving equations. Let's look at 3 examples of solving equations.
Is this all taken from the Hayes book?
Yes. So if I want to solve this, the key to solving exponential equations is have the same base on either side, so you can make an equivalent statement. So what's the base number I'd use between 4 and 8? 2, yeah, go with a prime base, yeah, so 2, 3, 5, 7. We'll do logs eventually, but not today. So that's 2 squared x plus 2 cubed. And now we have this thing called an equivalence statement. If that equals that, then that must equal that. So 2x must equal 3. So I'm just taking the exponents down, saying that that must equal that. So x must be 3 over 2. The next one then, 9x to the minus 2 is equal to 1/3. Okay, so my base power here is looking like 3. So I'm going to rewrite this, 2x minus 4. Do we see that? Because that's 3 squared, so these are both going to be multiplied by 2, is equal to 3 to the minus 1. Okay? And now we have this equivalent statement again. 2x minus 4 must equal negative 1. So 2x then, add this over here, we get 3, and x is also 3 over 2. Okay? And then we'll do this last one, and then you guys can start on your work. So looking at that last question, what do we think it is? Can we recognize it this time? It looks like a quadratic. It's got 3 terms. This one is going to be a square of some sort. How do I make it a square? Yeah, 2 to the 2x, or you can go 2x if you prefer to write it like that. So you can, I prefer to do that variable switch to just say, right, from now on, I'm just going to say this. That's just a. And that's nicer just to look at. You can do your quadratic with this and then put this in afterwards. So that's, if I factorize this quadratic, I get 5 and 4. I think plus and minus works. And then I've got to let, okay, so a minus 4 equals 0, so a is equal to 4. And a plus 5 is equal to 0, so a is equal to minus 5. And then I go, right, but we're not dealing with a. Whatever a was all along, a is just a placeholder for 2 to the power of x. So 2 to the power of x equals 4. And 2 to the power of x equals minus 5. So I need to finish. Yes.
Yeah, no, I see that.
Oh, we'll get to that. Let's do this one first. What's x from here? X must be 2, because 2 squared is equal to 4. That's one answer. What's the answer here? It's disgusting. Okay. I don't know. What do we know about what do we know about the there's no answer? There's definitely an answer. Or is there definitely an answer? What do we know about the function 2 to the power of x? What would it look like? Don't do that. What would it look like if I drew it? It's an exponential function, which does this, doesn't it? Okay. So where's it across the y-axis?
-20. -5. Never mind.
This one. Just solving this now. I've already made this an easier thing to solve. So just this function itself, just solving that bit. Where'd it cross? Not the -5 bit, just this. Where does this function? So we're trying to find where this function equals -5. When we say equals -5, we mean that it crosses this line. The -5 on y, isn't it? It's not the input, it's the output. So will this line ever cross that? No. So there is, Richmond is right. There is no solution for that. Just to confuse you. No, but you got to think about that. Any exponential function will not give a negative answer. How do we get a negative answer? Because even when we have a negative power, that's a positive number. So it's a small number. As we can see, this is getting smaller and closer to 0, but it's not going to quite reach there. Yeah. All right. Okay, you guys can start your homework. It's just a bunch of these.
Homework.
Yeah.
For when?
For Thursday.
No. How many questions?
As many as you want.